So in this video, we will see what is Turing machine. Okay. So we have till now we have seen FSM, that is finite state machine, and then we saw push down automata. Finite state machines are accepted. Finite state machines accept regular languages. The limitation with FSM is that it has a very limited memory. Okay, it doesn't have a storage. So A power n, B power n kind of languages it cannot accept because you have to store the value of n. Okay, so that's why we go for PDA, push down automata. Push down automata accepts context-free languages. PDA accepts PDA is powerful than the FSM. Even then, there are a few limitations in PDF. We move on to the Turing machine, which accepts recursively innumerable languages. Okay, Turing machine is a computational device. It is a computational device used to explore the limits. Okay, what a computer can do and cannot do. Okay, it helps to prove that certain languages and problems have no algorithmic solutions. Okay, it aids the users, whoever is using the Turing machine, to tell them whether this can be solved using an algorithm or not. Okay, so FSM had a input tape. FSM had an input tape of this form, right? You give a input, okay, moves on. So then PDA had a input tape and stack, okay, input string and a stack, okay. But Turing machine has a input tape, okay. Turing machine has an input tape, but the input head can move both directions, for both forward and backward. Say this is the input tape. Okay, so your input is A, A, B, B. After this, it is all blank spaces. Okay, so this is a in tape head. This tape head can move right and left both, but only one step at a time. It can move both right and forward and backward. It is an infinite tape. Okay, so if your string is filled, like if your string length is 4, rest of the tape will be filled with blank spaces. It is an infinite tape. Okay, the tape alphabets are like same way sigma. Input symbols are represented using sigma, right? It can be 0 or 1, A, B, okay, X, Z not. These are all your tape alphabets. And we have a special symbol called blank in Turing machine. Okay, this can be represented using this symbol or B or capital B. When you use this B, it will get confused with the terminal symbols that we use, right? A and small b. That is why most of the time we will use this blank symbol. Okay, this blank symbol is not your input. Okay, it is just a special character. It is not your input. So this does not belong to what? Your input. Okay, what are the operations that you can do in a Turing machine are you can read, you can read or scan. Okay, you can read a symbol or scan. Okay, and update or write, update or write, and move the tape head one step right or one step left. Okay, these are the operations that you can perform on a tape head. Okay, the rules are you if you are reading something. Okay, so read the current symbol. If you are reading a symbol, read a current symbol. If you are reading a particular symbol, okay, you can update only that symbol. Update the same cell. Okay, if you are reading something, you update, or if you want to update, you update the same cell, not the next cell or the previous cell. Okay, you can either move left or right, only one step, only one step. So these are few rules in implementing a Turing machine. Let's see how the transition looks like. Okay, say for example, this is one state called Q0. Okay, you are moving to another state Q1. Okay, So the input symbol is A. You want to replace this A with something else, say X, okay, and move one step right. Okay, so this is how you write the transition. This can be written like A, okay, comma X, comma R, or you can use a vertical line also, A, X, comma R. This is these three, I mean, the transition can be written in these three ways. So this is your like input symbol, input symbol. This is something that you are going to replace with symbol to write, symbol to write or update. Okay, this one is where to move, left or right, direction, your direction. Okay, so if you don't want to update anything, you don't want to replace A with anything, so you how that you can write is A, don't replace with anything but A. A replace with A, move right or left. Okay, so this is how the transition looks like in a Turing machine. Then we'll see the formal definition. Okay, Turing machine is also a seven tuple seven tuple machine. So it has Q, okay, sigma, tau, delta, Q naught, B, and F. So Q is your non-empty set of states. So if you remember in FSM and PDA, it is finite set of states, but in Turing machine, it is non-empty set of states, and sigma is your non-empty set of symbols, input symbols. Okay, tau is your non-empty set of tape symbols. So input symbol is different, tape symbol is different. For example, your string contains A and B, the input symbols are A and B. But a tape will contain A, B, and blank symbols also, right? Blank also. And if you are replacing A with X and B with Y, then your X and Y also blank symbols. Sorry, tape symbols. So now what and all would be in the tape A, B, X, Y, blank. All these are your tape symbols. So input symbol is different from tape symbol. So now delta is your transition function. Okay, so transition function is Q into sigma tends to tau into R or L into Q. So here say the state is Q naught. Input is A. Okay. So anything from the stack alphabet. Okay. If you want to replace A with X, okay, into which direction you want to move. Right. Into which state you are going to Q naught. Okay, this is the transition function. Then Q naught is initial state like always. Okay, then B is your blank symbol. Then F is your set of final states. So Turing machine has can have only two final states, that is either reject or accept. So Turing machine is a deterministic machine. What do you mean by deterministic? If the input alpha, if inputs are A comma B, each state should have the transition for both the alphabets. Okay, if it is not accepting B, then you send to the dead state, right? So you don't have to mention explicitly, like you mentioned in FSM, all the transitions. In Turing machine, it is understood if there is no transition present for other inputs, then that particular string is rejected. Okay. So you don't have to give transition for each and every state in Turing machine. If there is no transition for B, then obviously that particular string is rejected. So this is all about Turing machine. In further videos, we'll see some examples for Turing machine.